Namaste, my friend, and welcome to JEE Physics with Typical Monk. This is class 11, and today we sit down to understand heat itself. Every rod that grows in the sun, every cup of tea that cools on the table, every gas molecule racing invisibly through the air around you, all of it obeys the same small handful of rules. When Sarah first met a calorimetry problem, she plugged straight into a formula and forgot to check whether the ice had actually finished melting, and the whole answer came out wrong. Today we make heat fully calculable, no surprises left. Take a slow breath. Let us begin. So what will you carry home from today's class? First, thermal expansion, linear, area, and volume, and how the three coefficients are linked to one another. Second, calorimetry and latent heat, mixing problems that include a phase change. Third, heat transfer, conduction's Fourier law, convection, radiation, and Newton's law of cooling. Fourth, the kinetic theory of gases, Arm's average and most probable molecular speeds. And fifth, degrees of freedom, the equipartition of energy, and the mean free path. Ready? One idea at a time. Let us start at the simplest place, how a solid grows when it is heated. First, linear expansion. A rod grows only along its length. Delta L equals L naught times alpha times delta T. Second, area expansion. When a flat sheet grows in every direction across its face, its coefficient beta is always double alpha. Third, volume expansion. When a solid block swells in all three dimensions, its coefficient gamma is always 3 times alpha. And fourth, water's odd behavior. Between 0 and 4 degrees Celsius, water actually contracts as it warms, instead of expanding. That is the one famous exception. Look at this diagram carefully, because all three expansions are really the same idea, carried one extra dimension further each time. First, linear expansion. A rod grows along its length, delta L equals L naught alpha delta T. Second, area expansion. A flat sheet grows across its face, and beta is always double alpha. Third, volume expansion. A solid block swells in all three dimensions, and gamma is always 3 times alpha. And fourth, the real-world consequence. This is exactly why railway tracks leave expansion gaps, and why a bimetallic strip bends, because two different materials expand at different rates. David used to wonder why railway tracks had gaps at all. Now you never will. Now, the one idea that decides every mixing problem. First, the principle of calorimetry. The heat lost by the hot body equals the heat gained by the cold body, provided nothing escapes to the surroundings. Second, specific heat capacity C. How much heat one unit of mass needs to rise by 1 degree Q equals mc delta T. Third, latent heat L. The heat absorbed or released at a constant temperature during melting or boiling, Q equals mL. And fourth, water equivalent. It folds the calorimeter's own heat capacity into the mixture as an equivalent mass of water, so nothing is left uncounted. Time to solve the full G numerical together, slowly, the monk's way. 100 grams of ice at 0 degrees is dropped into 300 grams of water at 50 degrees. Inside a perfectly insulated calorimeter. Find the final temperature. Given water's specific heat as 1 calorie per gram per degree, and ice's latent heat as 80 calories per gram. Step 1. Write down what is given. 100 grams of ice at 0 degrees, 300 grams of water at 50 degrees. Step 2. Check first whether all the ice melts. Heat needed to melt all the ice equals 100 times 80, 8,000 calories. Heat released cooling the water from 50 to 0 equals 300 times 1 times 50, 15,000 calories. Since 15,000 is greater than 8,000, all the ice melts. Step 3. The leftover heat. 15,000 minus 8,000 equals 7,000 calories left over to warm the mixture above 0 degrees. Step 4. The heat balance. The total mass is now 400 grams. So 7,000 equals 400 times 1 times delta T, giving delta T equal to 17.5 degrees. Step 5. The final temperature equals 0 plus 17.5. So 17.5 degrees Celsius fully liquid with no ice left. Notice the method, check first, then balance. That single habit solves every calorimetry problem JEE can ask. Now, how heat itself travels and how gas molecules actually move. First, conduction. By Fourier's law, dq over dt equals minus Ka times dt over dx. And when rods are joined in series, their resistances simply add. Second, convection and radiation. Convection needs a fluid that can actually move, but radiation alone can cross a vacuum with no medium at all. And cooling always follows Newton's exponential law. Third, the Maxwell speed distribution. The peak of the curve gives the most probable speed, the middle gives the average speed, and the long tail pulls the arm speed the highest of the three. Arms is always the largest of the three, for any gas. And fourth, equipartition. Every degree of freedom carries, on average, half kT of kinetic energy. The more degrees of freedom, the larger CB becomes. Lisa used to think average speed and arm speed were the same thing. This diagram cured that for good. Now sit up straight. These 5 lines are what JEE actually asks, year after year. 1. VRMs equals the square root of 3RT over M. Remember, T in Kelvin, and M as the molar mass in kilograms per mole. 2. Mayer's relation, Cp minus Cv equals R, holds for 1 mole of any ideal gas. 3. Degrees of freedom, 3 for a monatomic gas, 5 for a diatomic gas, or 7 with vibration at high temperature, and 6 for a non-linear polyatomic gas. 4. Thermal resistors combine exactly like electrical resistors. Series adds resistance, parallel adds conductance. 5. The pair beta equals 2 alpha and gamma equals 3 alpha. Links all 3 expansion coefficients. A favorite one-line question. Let us drill the JEE way. Remember the 4 options. Option A, both statements true, and the reason explains the assertion. Option B, both true, but the reason does not explain the assertion. Option C, assertion true, reason false. Option D, assertion false, reason true. First one, assertion, the M's speed of gas molecules rises as temperature rises. Reason, the average kinetic energy per molecule, 3/2 kT, is directly proportional to absolute temperature. Think like SATA, check each statement, then the connection. Both are true, and the reason fully explains the assertion. Option A. Second one, assertion, 2 rods of the same material but different lengths, carrying the same temperature difference, conduct different amounts of heat per second. Reason, thermal conductivity K depends only on the material, not on the rod's geometry. Both statements are true. But pause. Does the reason explain the assertion? No. The length effect comes from R equals L over Ka, not from K being material only. Both true, but the reason does not explain the assertion. Option B. Third one, assertion. The mean free path of gas molecules decreases when temperature is raised at constant volume. Reason, mean free path depends only on the number density of molecules, not on the average speed. Check the reason first. It is true, mean free path really does depend only on number density. Now the assertion, at constant volume the number density does not change, so the mean free path does not change either. The assertion is false, the reason is true. Option D. This is the trap that catches John every time. A quick match now. Say each formula aloud before I reveal it. VRMS, the square root of 3RT over M, the fastest of the 3, because of the squaring. The average, the square root of 8RT over pi M, the middle speed of the 3. V most probable, the square root of 2RT over M, sitting at the peak of the curve, the slowest of the 3. And Cp minus Cv equals R, Mayer's relation, true for 1 mole of any ideal gas. If all 4 came to you before the reveal, kinetic theory is becoming yours. Use a favorite JEE format. I will read some statements. You silently count how many are correct. Statement 1. A diatomic gas at moderate temperature has 5 degrees of freedom. Hold your verdict. Statement 2. Convection can transfer heat through a perfect vacuum. think about why convection needs a fluid at all. Statement 3. Newton's law of cooling holds well only when the temperature difference between the body and its surroundings is small. So, how many are correct? Two statements, the first and the third. A diatomic gas truly has 5 degrees of freedom, and Newton's law only works well for a small temperature difference. But the second one falls. Convection always needs a moving fluid and cannot work in a vacuum. Two correct, and the middle one is the trap. Now let me save you some marks. 2 myths that trap thousands of students every year. Myth 1. Average speed and arm speed of gas molecules are the same thing. It feels so natural. Surely they both just describe how fast the gas is. But here is the truth. They differ. Scoring before averaging always makes V RMS greater than V average, and V average greater than V most probable. Myth 2. Radiation needs a medium to carry heat, just like conduction and convection. The truth, radiation is the one mode that can cross a vacuum. It needs no medium at all. One myth, one 4G question. Do not let it be the one that costs you. Time to test yourself, rapid fire, and every answer today is a number. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just what you built today. Question 1. A 2-meter rod, alpha equal to 12 times 10 to the power minus 6 per degree, is heated by 50 degrees. Find delta L 1.2 millimeters. Question 2. What is VR mass of oxygen? Molar mass 32 grams per mole at 300 Kelvin. About 483 meters per second. Question 3. What is Cp minus Cv for 1 mole of an ideal gas? About 8.31 joules per mole per Kelvin. Question 4. How many degrees of freedom does a diatomic gas have, ignoring vibration? 5. And question 5. The thinker. 2 rods of the same length and area, thermal conductivities K1 and K2, joined in series. What is the effective conductivity? 2K1 K2 divided by K1 plus K2. If you caught that one, you have truly understood today's class. Let us gather the whole class in one slow breath. Thermal expansion, beta equals 2 alpha and gamma equals 3 alpha. Link all 3 coefficients. Calorimetry, heat lost by the hot body equals heat gained by the cold one, but always check first whether a phase change actually completes. Heat transfer, conduction obeys Fourier's law. Only radiation crosses a vacuum, and cooling always decays exponentially. Kinetic theory, B RMS is always greater than B average, and B average is always greater than B most probable for any gas at any temperature. Equipartition gives half kT per degree of freedom, and that single number fixes Cv, SCP, and gamma for every gas. And next class, class 12, the next chapter in the JEE Physics Q. Do not miss it. And so, my friend, we have made heat fully our own today. It may have looked like just growing rods and a cooling cup of tea, but understand this. This is the language of all thermal physics. Every numerical G will ever throw at you rests on the same calorimetry, the same conduction, and the same kinetic theory that you learned to read today. Sarah, David, Lisa, and John all started exactly where you are right now with this one class. Be patient with yourself. Tonight, revise this order once, slowly. VRMs is the largest, V average sits in the middle, V most probable is the smallest. One idea at a time, you will crack G, of this I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you in the next class.